Now let us try to understand the Profile Studio tool that is used for the top-down engineering of IEC 62850 based devices. I will click on the Profile Studio icon to open up the tool. The Profile Studio translates station bus or S-bus system architectures, which is IEC 61850 based, and L-bus system architectures, which is Modbus 104 based, into human comprehensible vocabulary for HMIs. This is done by importing compatible IEC 61850 based SCD or substation configuration description file. The Profile Studio detects the types of data points inside the SCD file, such as alarms, set points, positions, etc. You can use the Profile Studio to manage data acquisition by assigning profiles to data points and editing their descriptions. You can either assign profiles automatically or manually. The project data in your Profile Studio project comes from your SCD file. The first screen that pops up displays two options where you can either open an existing project or create a new project. I will create a new project by clicking on the Create New Project button. I will give the project a name. Choose the language from the drop-down. You have options of either English or French. The project type is chosen accordingly. You can determine whether to configure your devices for Echo SUI and Echo Gateway by choosing EPAS, or for EcoStruxure Power Operation by choosing EPO. In our case, it is EPO. Click on Browse and choose a location to save the project to. Here I've created a folder called Profile Studio Projects where I could save all my Profile Studio projects. I'm going to click on Select Folder. To import devices and data points, you have two options. Either you can use the EPAS engineering project or use an existing IEC 61850 SCD file. We will choose the IEC 61850 SCD file option and click on Create New Project. A window opens up to import the SCD file. Let us select the SCD file that we have and click on Open. This window shows the SCD file information. Click on OK. Once you are into the Profile Studio, let us try to understand the interface. Under the navigation window, the electric hierarchy classifies the information according to substation voltage level and bay. The system hierarchy classifies the information according to its network and subnetworks. Now let us understand all these icons at the top, which have different functions in the Profile Studio interface. Use the Save button to save the changes you make to the project. The next icon is the Export Project option, which is the final step in adding the devices after configuration. After configuration, you could either export a configuration package in the form of a zip file for all equipment or for selected equipment only. Use the Merge button to merge the changes from the SCD file or from the EPAS-E project or the database. Use the Validation button to check the project for any errors. The Profile Studio is used to either manually or automatically associate profiles with data points. So you could use this button to automatically associate profiles. This icon or this button shows SCD history. Clicking on this button will open up the Search and Replace description. You could use it to search and replace the description according to the options below. You can choose the interface language from the Settings button. The Equipments tab refers to the intelligent electronic devices that receive data from data points. In Profile Studio, the equipment pane reflects the IDs in your project. These are grouped by subnetworks such as IEC 61850, 104, Modbus serial, Modbus IP, etc. The purpose of the equipment pane is to configure each subnetwork with its matching protocol. Here is where you would configure the IP address of the power operation. The Data Points tab has data points from the SCD file. Data points appear in the Data Point tab in gray until they're assigned to a profile. You can also right-click on a data point and choose Reach from the context menu to view to which node the data point belongs to in the navigation pane. So the first step after you open up the project is to assign the profiles. This could be either done manually or automatically. We will explore the automatically assign profiles option by clicking on auto assign profiles. In the automatic profile association dialog under data points source, choose one of the following, either the project, the data grid, or the selection. Under settings, you can enable or disable the following: assign already assigned data point, or like previously assigned data points, assign unassigned data points, or unassign previously assigned data points. I would go with the default option because we are yet to assign profiles to all these data points. So I would choose the project and I would choose assign unassigned data points. So as you see, some of the points turned to black from gray, which means that they have an assigned profile, which can be seen from the profile column. As you see here, there are some points which are missing the profile. So you could choose to manually assign profiles to them by clicking on the configuration tab. So there are many profiles defined here. SPS talks about the single point status, DPS talks about double point status, MPS talks about multiple point status, MV is measurement value, then you have a string profile, then you have set points, then you have SPC, which stands for single point control, and DPC, which is double point control. Now let us see how to manually assign a profile. Either you could choose the type of profile you want from here and then click on the assign profile, or you could drag and drop the kind of profile that you need by selecting it and dragging and dropping it onto the profile column. So this one seems like an SPS. It is single point status. If I read the description, it's system logical device VT fault. So I would choose single point status on or off, right? I could click on this assign profile, which assigns the profile to that particular signal. In the lower section of the configuration pane profiles tab, details appear for the selected profile. These include key, which is the state's name, label states the label, archived says whether it is archived or not, yes or no, printed says if it is yes or no, the alarm level, if it is 1, it is alarmed, if it is 0, it is not. Then you can also have an alarm delay in seconds, and you could also choose all these options. Right now, the trends and alarms are yet to be managed in the PowerSCADA Studio, so we will leave it at that. Then you have the advanced search tab that lets you search information with a variety of options. What is also important to understand is whether your point or a signal is subscribed to the power operation. As you see, some of the points have a green check button, which means that they are subscribed to the power operation. Some of them are not subscribed. This is again managed from the EPAS-E tool, and you could choose to subscribe to the power operation from the EPAS-E tool. Once you have configured or assigned the profiles, and once you have also finalized the descriptions, you can click on the export full configuration package option. Click on OK and choose where to download it. As you see here, we have received a zip file. I will unzip it. You have an equipment.csv file that can be used to add multiple devices in the IO device manager. You have equipment profiles.xml that contains the profiles of the equipment. You have an export results log and the SCD file that is contained. So next step is to open up the Excel file or the CSV file called equipment.csv. We need to add the clusters and the IO server names that are defined in the project. So my cluster here is C1. I will do this for all the profiles. We also need to define the IO server. So in my case, the IO server name is IO server 1. All these devices are talking to the same IO server. So I'm going to enter the IO server name here. Save the file. You would also notice that the BRCB and the URCB names are automatically populated into this Excel file. So we have all the information that you need to instantiate the 6250 devices that are in the SCD file. Now we would open up the IO device manager. Choose the import devices from CSV option. And choose the equipment.csv file. You would also point the equipment profiles.xml file that is contained in it. So this was the equipment.csv file. And I have to make sure that I point out the right equipment profiles XML file, which is in the same zip folder that the Profile Studio gave us. Make sure that the CSV file is not open. So I'm just going to close the CSV file. Click on Validate CSV. And click on Add Devices. As you see from the project window in the IO Devices tab, all the 6950 based devices that were in the SCD file have been added into the project. Now we are good to go. You could visualize the data either in the graphics editor and then try to look at the variable information. Thank you.